Hi, this is ET370 Lab 3, and here we're going to explain Lab 3 and kind of go through all the things we want to introduce. The first one is how do we implement non-blocking code? And so we want to make sure that we are able to implement something where there is no delays. Delays are bad, okay? And so this is a tool here where we can eliminate a delay function where you're stuck and the Arduino can't move on. Then we'll also look at how do we detect a button transition. So that'll be explained over here. And so we're going to reuse our button code and LED code from homework 1 and homework 2. And then we'll introduce this concept of state machine. This should be very useful when you want to have the Arduino kind of switch from mode to mode. And we'll use this new concept, switch case. This is a nice feature of a lot of programming languages to implement state machines. But let's begin. Okay, so what I want you guys to do in this lab is to literally type in lines 1 through 19 here, okay? And this has a new variable called change time. We're going to use this new concept or this new tool in Arduino called millis. And this is basically asking what time has passed since the Arduino has powered up. And the units will be milliseconds, all right? And then we'll have this guy here in the loop that runs over and over and over. And this is a nice way of only executing what's inside these if curly brackets when 1 second has passed. And here, let's read out what is going on in this if condition. If the time, right, if the time since the Arduino started minus change time, okay, so this change time has been initialized to the time before what came in the loop. And if that difference in time is greater than 1 second or 1,000 milliseconds, come into here. And then what you have to do is you have to reinitialize change time to be the new value of the current time. And so the idea is the loop will execute over and over and over. And this, the majority of the time, lines 13 through 17 will be skipped, all right? And every time 1 second passes, it'll come in here and then be able to run it once, but then it'll run the loop over and over. And so the idea is this line here, everything outside of this if statement can run every loop cycle, whereas this stuff inside runs only every second. I have this implemented. So we go to our Tinkercad and let's go over here. I already have this programmed in, but you guys would just have to type it in. And what you can do is just open up a blank Arduino sketch and type in that code. I have it typed in. And when you start the simulation, what you should see on the serial monitor is the majority of time you can see this line of code is saying run every loop cycle. Now, every time a second passes, you can see this quickly pass by runs only every second, right? And I know the Tinkercad is running slow. You can see the Tinkercad, actually the timing is right here. So 1 second is actually a lot longer in Tinkercad seconds, but you can see every time it hits 6 seconds, boom, you can see that runs only every second. 7 seconds, it goes again, 8, so yep, there we go. So every time the Arduino, every time a second passes in Tinkercad, you can see this guy gets fired. Now, don't forget, this line in 15 is very important. This updates change time. So let me run through this again. Change time is set to the current time. All right, and millis is going to give you that current time. And now this is constantly checked every loop time. So it's asking, is the current time minus that fixed time greater than 100 or 1,000, sorry. Okay, usually no, the answer is no, 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 no. Finally, because the current time is growing, this will surpass 1,000 and come in and reset change time to the new current time, okay? And then once it leaves and it comes back to check again, well, if this was, for example, at 1.3 seconds and this is 1.4 seconds, right? It's not going to meet this and it's going to keep skipping until we get to 1 more second that's passed. They'll come in and update this, okay? So I hope this is a nice way for you guys to implement kind of delays or a way to have something occur without doing a delay. All right. Okay, so let's stop this and go on to the next part. So in the next part here, oh, and by the way, I forgot to mention, why are we using an unsigned long here? So an unsigned long is another data type. What's nice about an unsigned long is it's 32 bits and it can contain 4.3 billion positive integers. And if that's in units of milliseconds, you can do the math and you'll see that this is actually about a month and a half. So it'll take a month and a half for this change time to overflow. Kind of crazy. So that's kind of nice. Okay, so let's look at the second program. So the second program is pretty simple here. Second program, we're just going to implement the button code. So I want you to just basically copy and paste your homework 1 or homework 2, but you just need an LED connected to pin 9 with a 220 ohm resistor and a button with a 10K with a pull down connected to pin 2 here, okay? And we're just going to open up buttons. So how do you get to button? Go to File, Examples, Digital button here. Take that code and then just copy it in, right? And run it. And you guys know what happens. You have to hold the button down, the LED turns on. You release the button, the LED turns off. Kind of boring. Now, what if we want to have something that detects the transition here, okay? So if we want to have something that detects the transition, and then later in the fourth program, we're going to have it such that when you push the button down, it'll turn the light on, and we push the button down again, it'll turn it off. It'll toggle it without having to hold the button. But what we're going to do is first look at how do we detect that transition, that rising edge, okay? So I want you guys to get this set up, and we'll have that ready to go so that we can check the transition, right? And so what I want you to imagine is, well, let's go and just see what that looks like. So if I go to button, what do we have for the button code? I can open up the button here. You guys have seen this before in previous labs, but let's look. Oh, by the way, you want to change this number to the number 9, and we're going to just literally copy that in. And we can do that. Watch this. So I'll just take this. Why not do this? Control A, Control C, come here to Tinkercad. And you can go, let's see, let's go back here. And what I'm going to do is just go to, let's see, can I open up a new one? Yes, I can. I can just open up, duplicate one of these. Yep, perfect. I'm going to duplicate that. And I'm going to go in here and then Control A, delete everything in here because I already have my nice button. And this is the button code, right? And I can run this code and you can see that the button is detected. If the button state is high, I'll turn on the LED. Yep, and if I release it, the LED turns off and that's here. So you've seen this already. Okay, so we can see that we're recording the button state. We've taken in, we have the button pin, LED pin, and we've initialized the button state to 0, right? All stuff we've seen before. Now this button state is going high and low, right? 0 and 1. And I drew an example situation where every time it goes through the loop, depending on if you press the button here, this is what Arduino sees. So if I don't have the button pressed, they'll see button state will be 0. If I press the button, it'll see 1, 1, 1, 1, then 0, 0, 0. I let go of the button. I press the button for a short amount of time, release it, press it, release it. And notice the rising edge transition from when the button goes from low to high occurs at these red circled sections. And let's look at what's the difference between this state and this one, right? Okay, why aren't these ones circled? Well, if you look at this point right here, it's not circled because look at the previous one. The current state is 1 and the previous one is 1. Here, the current state is 0 and the previous one is 0. But here, this is a special case where the current state of button state is 1, but the previous button state is 0. And that only occurs on these red circled intervals, right? Now notice here, this is actually a falling edge where the current state is 0 and the previous is 1. But let's say we're only concerned with the rising edge, okay? So if we are only concerned with the rising edge, can we program it in and detect a rising edge in Arduino? And so what we'd want you to do here is initialize a new variable called button state previous and initialize it to 0. And then we want you to set up the serial monitor. And right above, so if you're in here, right above this, we want, actually, I'll do it for you. So watch this. So we can type, I'm going to stop the simulation and we can do it. So int button state previous equals 0. And I'm going to put in here the serial monitor, serial.begin 9600. Good. And right here above this, I'm going to say button state previous equals button state. And so what this is going to do is this is going to store the previous value before you update and read the button again. Okay. So I have a button state previous and the button state. And if I look here in my if condition, what it's saying is if my button state is high and see this double ampersand, my button state previous is low, I will know that my button press was detected. I will know that I've hit these red lines, okay? Otherwise, it will not click. So let's do that. So I'm going to go in here. I'm going to replace this. So I'm going to delete all that. If button state is high and button state previous equals low. Notice I have two equals, curly bracket, curly bracket. So I got to make sure my curly brackets are all set. So here this is my curly bracket for the loop. This is my curly bracket set for my if. I'm going to say serial.println. I'm going to say button press detected. Okay, so that's what I have here. So let's see what happens when I run this simulation. Now the LED is not in play. That's okay. We're just serial printing. So I'm going to start the simulation. No errors, hopefully. Good. And let's look at what the serial monitor has to say. So the serial monitor is saying nothing, but once I hit the button, look at that, button press detected. And notice it only says it once, and it doesn't keep streaming it. Watch, even if I hold the button down, it only says it once, and when I release, nothing happens. So every time I click, so this is only occurring once every button press. That's nice, okay? So we now have a way of detecting just the transition. This is going to be important for our state machine stuff later, okay? All right, now let's combine this into a way to toggle back and forth. So I want to be able to hit the button and turn the LED on and hit the button, turn the LED off. So this is going to introduce our state machine idea. Okay, so I hope you can see the intention of what I want to do here. I have two states, and what I can do is I can define a state variable to the value 1, and I'll initialize the LED now to off. And if I'm not doing anything, the LED will just stay off. But let's say I'm in this state and I detect that I pressed a button using this kind of concept here, right? What I can do is I can set a state variable to 2 and turn on the LED. Now the LED is on, it's just staying on. But what it's looking for is another transition, another button to escape and go back to state 1 and turn off, okay? And the way we're going to implement this is with a switch case, okay? And I want you to also notice that this is not going to require any delays, okay? So this is actually nice. It's non-blocking, has no delays, and yeah, let's see how we would implement this using this new switch case syntax. All right, and what I've drawn here or written here is the pseudocode. Okay, so I have the pseudocode, and the pseudocode, remember, is fake code. So the idea is I'm going to initialize the state to 1. I'm going to still initialize the button state and button state previous to 0. Initialize my button pin, LED pin, all the baud rate, but I'm going to turn off the LED. Okay, so this is the new thing. Set a state variable to 1, turn off an LED. Okay. Now I'm going to have a switch state or a switch case. So I'm first going to detect the button and also store the previous button state here, just like I did before. But this is new. This is very new here. So what these lines of code does is it looks at this variable called state, which is initially 1. And then it's going to, well, since it's 1, it's only going to execute this set of code, and it's going to ignore this one and skip it, which is nice. And it's going to just do this. It's just going to sit here and just do this. So I apologize, not sit here. It's going to execute here, okay, and then skip this part and then keep going. Now, if I don't press the button, this part here does not get activated, right? Once I press the button, look what happens. It turns on the LED, sets the state to 0 or to 2, and then leaves. And the next time it goes into the loop, what's going to happen? It's now going to go into this bottom part. Okay, and this bottom part, it's going to keep sitting here or doing this until it detects a button press, and then it's going to turn off the LED and set the state back to 1. So I hope you can see this is switching back and forth, back and forth. So what would we want you to do? So what we want you to do is first declare a state variable in state equals 1 just at the beginning, okay, just like you have to do here. And then this is the more specific syntax of what you could literally type into Arduino, and notice that is going to be exactly what you have to code up for the pseudocode. So we've given it all for you, but we're breaking it down in a very slow way. So let's look at this carefully. So this is the syntax for a switch case. Switch state, parenthesis, parenthesis, and look at this curly bracket from here all the way down to there. Okay. Now look at the two cases, case 1 colon, case 2 colon. And every time you write a case, you have to have a break. In this case, you have to have a break. Now what this is going to print is I'm in state 1 or I'm in state 2. But this is your exit condition. These are your two exit conditions. And these two exit conditions, these ifs here or this if here, represents these arrows that leave the states, okay? All right, so what is it saying? Oh, we've seen this before. If the button state is high and the previous button state is low, we've detected a button, yep. And we're gonna turn the LED on and we're gonna say state equals 2, and then we're gonna break. And these breaks will leave the switch case, okay? Not the loop, but the switch case. Look at this side. If you're in case 2, notice you have the same button detect code written, but now you're going to say turn off the LED and go back to state 1. Okay, so I hope this makes sense. And let's look at an implementation of it. So if we go here, I'm going to go back. And I have here, I have it already coded up in an example. So let's click here. And here I'm going to click code. Okay. Oop, sorry. This is not the right one. This is program 3. I want to go to program 4. Apologize. So that's this one here. Okay, so I go to code, and here we go. We have our two states, right? Case 1, case 2. Good, perfect. And let's see what happens. So I'm going to hit start simulation, and let's look at the serial monitor here. And so right now I'm in state 1. So the loop is cycling very fast. It's non-blocking. It's always looking at the button. It's always storing the previous button state, but it's just printing out this line. Okay. Now at any point, if I click that button, finally this part will get activated. What should happen? The LED should turn on and it should say button press detected, and then it's going to go to state 2. So watch this. Click. Notice, look, button state detected. I'm in state 2. The LED is on, right? And now I'm kind of hanging out here, right? So I'm still reading the button every time I go through the loop. Then I'm going to this part, skipping this, here, okay? And if I press the button again, I'm going to turn off the LED and go to state 1. Good. Button press detected. So now, if you look at the serial monitor, every time I press the button, it detects a button press and toggles between the two states. Notice the LED also fires too. Okay. So this is a nice, very simple two-state state machine, right? Where we're utilizing this button press. Okay, we're utilizing this nice button press. Okay. All right, so now let's combine this millis, this change time in millis, this edge transition, this two-state state machine with this fifth program here. Okay, and the intention of this program is to add a third state, and now we're going to start with the LED off. I push the button, the LED turns on. And here I'm going to push the button again. I'm going to turn off the LED, but check it out. Inside this state 3, we can have it do something. So what it's going to do is it's going to wait 3 seconds and it'll automatically turn the LED back on. So LED off, on, off. And if I don't leave, it'll just turn it on. Now here, at any point, whether I'm on or off, doesn't matter. I can always press the button again and go to state 1. Now, what do I have to do? That change, remember that change time equals millis? I'm going to have to do that on the exit of state 2, okay? And the nice thing is, in this state machine diagram, I hope you're seeing that this is actually implemented directly into the pseudocode. So let's look at the pseudocode. Initialize the state to 1. Good. Initialize change time to an unsigned long. Good. So we did that before in the very first program. Initialize button state and the previous to 0 and all the stuff for the pins and the LEDs, right? I'm going to turn off the LED. Now I might have to turn it on if I want the LED to be on in state 1, but this is in the setup, okay? And initialize change time to millis. Now this will get overwritten, so this step really isn't that critical, but it's just good practice. Okay. So now to follow this, what do you call it, state machine diagram, what do we have? I'm reading the button and storing the previous, and I have 3 cases, 1, 2, and 3. In the first case, if the button is detected, I'm going to cycle to state 2 and turn on the LED. If I'm in state 2, if I detect a button, I'm going to turn off the LED. I'm going to set change time to millis, and I'm going to set state equals 3. Now, if I'm in state 3, if 3 seconds passes, we just saw that, I'm going to turn on the LED. But at any time here, I'm also looking for the button to be pressed. At any time the button presses, I'm going to turn it off, and I'm going to leave to state 1. Okay, so I actually have the code for states 2 and 3 typed out here for you in case you're stuck, but try to just use just the pseudocode here and implement it on your own. Now I'm going to show you an example of it implemented for you. So let's go back to here. Okay, let me go back to there. And this is program 5. Boop, boop, boop. Yep, here we go. Okay, give it a second. And if I already have it all coded up, I have case 1, case 2, and case 3. Okay. And if I start the simulation, what I should see is, let me move this over. I'm in state 1, the LED is off. I press the button. I'm in state 2, the LED is on. I'm in state 3, and the LED turns off. However, if 3 seconds passes, now Tinkercad is slow. If 3 seconds passes, this light should turn back on, right? Okay, so let's wait. Give it a second. And there we go. The LED turns on. I'm still in state 3. I haven't left. And if I press the button again, I'll go back to state 1. The LED will turn off. Now, if I go through this quickly, I go to state 2, sorry, state 3, turn off. And I can leave back to state 1 at any time, right? I don't have to wait for the LED to turn back on. But that is the intention of this code, right? Okay. All right, so stop simulation. All right, so that's pretty much the lab. Hopefully not too bad. Now the homework will be a little bit more complicated, but if you understand the homework or the program 5, the homework's not too bad. The homework is 4 states, and now look, we're starting with the LED on. Ooh, so you got to do some stuff in the setup. You have it turn off, you have it turn on again, and you have it turn off. So you've actually, if you can do all these, or if you can do program 5, you can do these easily. Now, look at this, turns the LED off after 5 seconds. So that's the last part of the previous program. And you have one more exit condition for state 4. If you press the button, you go back to state 1, or if 10 seconds passes, you will go and automatically go back to state 1, okay? So there's 2 exit conditions for your state 4, all right? I've written out the pseudocode for you, right? So that's all written here. And look at this. We have 2 different ways of exiting. If the 10-second passes or the button press is detected, you can leave to state 1, right? But here, so I've kind of written out everything, and I hope this is This will be a fun lab, and you'll see the utility of this concept of state machine, detecting a button press, and non-blocking code in your projects. All right, have a great day, and see you at the next lab.